All right, our third reaction was already mentioned by Miss Catroni. And what was that?
What
Did you mention it? Was it good?
What? I don't know. Composition?
No.
Combustion?
Yeah. Who mentioned it?
Oh, burning.
Oh, burning. Oh, okay, it was you. Burning, yeah, okay. Combustion. And this is, burning. Burning's in there. And that's not really what's going on. I mean, burning, yeah, that's what we call it, but it's not really. You take hydrocarbon. And what's a hydrocarbon?
A water thing.
Hydro. What does that sound like? Hydro. What are you doing?
We're stretching for still very intensively.
How are you going to take notes? Get up here. What the heck? Okay, get them on film. Get them on film. Parents, I want you to see what your daughters are doing. Hydro. What does hydro sound like?
Water.
Hydrogen.
It does. Oh, yeah, hydrogen. Good. Hydrogen. And what does carbon sound like? What does carbon sound like? Carbon. Very good. So what do you think hydrocarbons have?
A hydrocarbon.
Hydrogen and carbon, right? And to that, we're going to put oxygen, magic sign, and you will end up with carbon dioxide plus H2O.
Wait, what's the A format?
There's no easy format for this one. I know. Yeah, I can't do it. I mean, I can do. And no, it wouldn't make no sense. This is instead of A, B, you have hydrocarbon. Now, what is the big boogeyman of combustion?
That all the stuff goes away. Gas.
Don't say global warming. No, global warming, no. I just thought of that. Please don't say global warming. No. What happens when you hear people using space heaters? What happens when people use space heaters in their homes? Like gas space heaters in their homes?
It gets hot.
Yes, it gets hot.
Things blow up.
No.
Not usually.
You go to sleep forever. Incomplete combustion. Incomplete combustion. What happens is you have a hydrocarbon plus oxygen, but your oxygen is actually less than you need. Less than is needed, magic sign, and you end up forming carbon monoxide plus water. Carbon monoxide is a killer, silent killer. Oh wait, no, that's heart disease. I'm sorry. Carbon monoxide. And this is why there's a big, if you have a hot water tank, ask your dad. If you have a gas hot water tank, the gas hot water tank has to be vented to the outside. It has to have fresh air, right? So you can get a plentiful supply of oxygen. If you don't have a plentiful supply of oxygen, you're going to form carbon monoxide. And carbon monoxide is bad because you breathe it in and your blood cells, your red blood cells say, hey, look, this is kind of like oxygen. And it goes into your blood cells, but it doesn't provide oxygen. And so you end up suffocating. And you end up just getting sleepier and sleepier and sleepier. That is not like school. Nobody goes to sleep in my class. But you just go to sleep. All right. Now we're coming to the really cool part. Those reactions are just kind of boring. Well, no, I mean, carbon monoxide is kind of cool. But, and burning things are kind of cool. Okay, no, forget it. That was the exciting part. Here comes the boring part. 4 single replacement. That just sounds cool, huh? Single replacement. Single replacement. I don't know. Single replacement.
Get a significant other.
Single replacement. Think about that. Single replacement. Yes, you're no longer single.
Single. Replace.
Well, the next one's double replacement. So that's X-rated. Single replacement. A plus BC, magic sign, goes to AC plus B. And this is where there's quintessential electronegativity problems.
Oh, using
Right.
big words now?
Because you got A is checking out C, and it's like, I don't really like C, I'm going to take C away from B, and that's what happens. It just rips this whole thing away.
Love triangle.
Yeah, that's what chemistry is. So an example would be magnesium plus hydrochloric acid, magic sign, magnesium chloride. What should this be? Magnesium combined with chloride. What should my units be here?
I don't know.
Magnesium forms what kind of charge? What?
Mg plus 2.
Plus 2? Chloride forms what kind of charge?
-1.
What should this be?
MgCl2.
Excellent. That's my son. That's my son answering the question right. Okay. And then, last but certainly not least, double replacement. I'm not sure if I got enough room to do double replacement.
Just erase single replacement.
Anyone got single replacement?
Yeah.
Are you writing stuff down? Oh, you are not. Are you? Oh, you're a deep creek. You are up a local reservoir without an adequate means of transportation. You're up a creek without a paddle. These aren't in your book. Not in your book. Not in your book. No, your book doesn't do anything. Your book is terrible. Your book says there's three types of reactions: combustion, combustion, formation, and decomposition.
So in other words, you're teaching us more stuff.
I am. You are just getting your money's worth today.
And you're making it
Wow. Yeah, exactly.
way harder.
Why? Because I'm just that kind of mean person. Yep. Yeah.
Yeah, you're making
Double replacement. Replacement. The replacements are a group, aren't they? Replacements. Teacher's assistant. Double replacements usually form participation. Usually form precipitates. Actually, they all form precipitates. Precipitate. I can't spell the word precipitate. I can barely spell it. Or I can barely say it. Precipitates.
If the teacher can't spell it, we shouldn't have to learn it.
No, well, that's just the unjust world. So here we're going to have A plus B, or AB plus CD. What do you think is going to happen?
ABC.
ABCD? That would be what kind of reaction? If you get A, B, C, D, what would that be?
I think you
We just talked about it. What, you're taking two things and you're forming one thing. Formation, yeah. No, formation.
I think that it would be AC plus BG or something like that.
It would be.
Or like
AB.
Or like-
Keep in mind now. Keep in mind. Keep in mind.
Dash AB
Typically-
plus C.
What would it be?
No, because then what if they do
or
that?
ABC.
It
By
could be
itself.
like A.
Well, there's a couple of choices we got.
It's the same thing as last.
Keep in mind, when we do ionic compounds, what do we typically do? We typically do the plus ion with a negative ion, so we have magnesium chloride, right? Plus, we call that a cation. We call this an anion, right? So, if we keep that up, we got a cation here, we got a cation here, we got an anion here, and an anion here. Do you think two cations are going to get together? No. There'll be nothing wrong with that. No, the cations will never get together. You can't have two likes. Two likes can't attract. Lots of comments that need to be made. Two, right? So what are we going to have? We're going to have this cation here looking at this anion over here and saying, oh yeah, hey, yeah, I like D. D's kind of cool. All right, and then we're going to have this anion over here checking out this cation over here, but we got to write it so that the cation always comes first. That's what it would look like. Everyone get that? That's important. Important, right? So you gotta write your cation with an anion. Cation with an anion. Right? Don't do this. Doesn't form BC. Right?
Why?
Because it just doesn't look good. And that's the, oh, look at this huge formula I got for double replacement. Alright. Double replacement.
We just did that.
I'm giving you an example. Silver nitrate. Oh, look at this. Look what I'm doing. Look what I'm doing. Magic sign. What?
What's the magic sign
Like
called
what's after?
It's just a reaction symbol.
Okay.
The reaction. It's the ink.
Alright. This is actually a pretty important reaction. This is how you titrate. If you're trying to find how much sodium's in something, how much sodium chloride's in something, you react it with silver nitrate. And you need an indicator, and the indicator would be potassium dichromate. So what do we have? What's this mean? Silver nitrate, is this a solid, liquid, gas, or what?
What? It's the
Quiet.
AQ, whatever that is.
Yeah.
What's aqueous mean?
Yes. Dissolved in water.
Yeah, so this is dissolved in water. How about our salt? This is just regular table salt.
It's dissolved in water.
Sodium chloride is dissolved in water. And we get silver chloride.
It's a solid.
It's a solid plus
It's dissolved in water.
it's dissolved in water. So what happened here? We have silver getting together with chloride, nitrate, sodium getting together with nitrate. Now, who can tell me the law of conservation of mass?
You can't just disappear. Mass can't just disappear, kind of.
Okay, no, that's it. Mass you can't create nor destroy mass, right? You can only change its forms. All right, so let's take a look. Let's jump back and see. Oh, everyone get that? Too late if you didn't. Let's jump back and take a look at our, I think it was a single replacement reaction. Yeah, our single replacement reaction. Magnesium plus hydrochloric acid. Incidentally, anything, magic sign, anything where you get a hydrogen written first, that's indicative of an acid. Ooh, what's an acid?
Something dissolved.
Yeah, it dissolves people, dissolves flesh, dissolves metal. Yeah, it's an acid, right? It's a proton donator. It's, yeah.
What's a very fast acting acid?
Nitric acid is really good. Yeah.
Somebody touched
Fuming
it.
nitric is good. What do you want to dissolve? See, it just depends on what you want to dissolve. Bones?
Sure.
Yeah, that's your best bet right there.
Nitric.
Yeah. There's that, what's that acid? Oh, you know what's really, fluoric acid. Hydrofluoric acid? This stuff's terrible. HF? HF. You get that? It literally reacts with calcium to form calcium fluoride, right, which is what you want for your teeth. But it rips the calcium out of your bones. So like if you get some of that stuff on you, it burns you, but it goes on further to dissolve your bones. It starts leaching calcium. So you got to go get calcium shots after you get hydrofluoric acid on. And then how about chlorine? Oh, this is the biggest side. How about what did they do during World War II? They used chlorine gas, mustard gas. Right, so mustard gas would explode and chlorine would go out, and inside your lungs you have water. Oh no, and water plus chlorine forms hydrochloric acid in your lungs.
What is this
And it
reaction
doesn't,
called?
what?
It's called mustard gas.
This is called no longer allowed by the Geneva Convention.
Then why are you teaching that?
Well, you know, it's just, fun stuff to learn. I mean, come on. So it's called mustard gas because it's yellow gas. It looks like mustard. But it forms hydrochloric in your
I'm
lungs.
pretty sure Iran's still making it. So they don't follow it.
Yeah, well, it's Syria, but there was a line. Obama drew the line. They better not be using mustard gas. And they used mustard gas. And he said, well, I really don't consider chlorine a chemical.
Yeah.
So
That's his side use.
he walked that back. Yeah, he doesn't really consider chlorine a chemical warfare. It's like, well, that's originally what was used in World War I, and the reason why we banned chemical warfare to begin with. But yeah, okay. All right, back to this. So, according to the law of the conservation of matter, is this chemical formula correct? Well, let's see. How many magnesiums do we have?
One.
Yeah, just have one. How many hydrogens do we have?
One.
Yeah, one. How many chlorines do we have? One. Magic sign. How many magnesiums do we have?
One.
How many chlorines do we have? Oh! How many hydrogens do we got? Look at this. We are making stuff. We are violating the terms set forth by in the law of the conservation of mass. And so what do we need to do in order to not violate the law and get a ticket?
Hide it, keep it the same.
This is where lots of fun comes in. We need to balance the equation. Now, balance the equation. Some people enjoy balancing equations, and we call them weird. Some people don't really enjoy balancing equations, and we call them chemists. I don't enjoy balancing equations, but it's something you got to do if you want to make chemicals. Gosh, everyone wants to make chemicals, huh? Making chemicals are fun. So we need to learn how to balance equations. And hopefully you won't turn out to be one of those that like to balance equations. I'm only kidding. There's nothing wrong with liking to balance equations. Some of them are fun. And there are some that are just like, oh my gosh, I don't see it. It is so difficult. But this one's an easy one. So what do we need to do? We need to somehow... What?
I think you should use this problem.
What are we going to do? The only thing we can adjust are the blank spaces out here. Right now, there's an understood one here, there's an understood one here, there's an understood one here, and there's an understood one here. We cannot, everybody said, we cannot adjust these numbers. These numbers are not for us to adjust. These numbers are for God to adjust. All right? And he's already adjusted them. And forever will they be that.
Maybe.
So, what can we do to get this to line up? What if we put a 2 in front of magnesium? Is that going to help? 2 magnesiums. No, that's not going to help us at all. That's going to make things even worse. Because magnesium is actually balanced here. 1 over here, magic sign. 1 over here.
Well,
2 in the other slot.
What other slot?
Right before the H.
2 here? No, that won't work. How will it? Let's see. How many hydrogens you got?
1, 2,
2. How many chlorines we got?
1.
2. Oh. How many protons have we got over here? 2. How many hydrogens? 2. My son once again got the right answer. And that's it. That's all you got to do for that one. Piece of cake.
But chlorine, there's not 2 of them.
Yes, there are.